It's full resolution, but it's all right.
Good afternoon. We'll try to get through these technical difficulties and give you a presentation here. My name is Kevin Murphy. I'm a program executive at NASA headquarters, and I manage the Earth Science Data Systems. The Earth Science Data Systems at NASA are the single largest repository of Earth science data, integrating multivariate and heterogeneous data from diverse observational platforms in the world. The Earth Science Data System program actively manages Earth science data as a national asset from airborne, satellite, field campaigns. Is that better? Okay. And develops capabilities optimized to support the rigorous science investigations for the current and future missions planned by NASA. We process and we reprocess these instrument data to create high-quality long-term records, and we support science and applications for societal benefit by hosting open data and open APIs using standards that anybody can use. Now, NASA Earth observation data is collected continuously, and for over 50 years, these invaluable records of the Earth processes have been providing a critical resource for science and researchers. Since 1994, we've been having a free and open data policy, and that has really allowed us to get data out quickly for any purpose soon after calibration and validation of the data. What many people don't realize, although you probably do, is that NASA has had Earth within its charter since the beginning, right? For the first 25 or so years of Earth observations at NASA, though, we didn't have a free and open data policy. We had a policy that was restrictive and something that PIs and institutions kept those products close to them and published first on them. There was a recognition in the mid-90s that this was not an effective way to extract the full value of those measurements. And so we adopted this free and open data policy. And it's been adopted by plenty of other government agencies and international groups since then. So today we really are in a golden age of open data for any Earth science observation types of activities. Now, open science provides a lot of opportunity for research, but it also provides a lot of headaches for the data systems that have to support that, right? Because we have to produce data and make it freely available with no period of exclusive access for anybody that wants to use it. So how does NASA do that? This is a bit of an eye chart, but basically what it is we do that by giving the data to the people that know how to manage it best and produce it best, right? The system is called EOSDIS, or Earth Observing System Data and Information System, which is a mouthful again, and it's composed of three primary components: SIPs, DACs, and Crosscutting Services, right? SIPs do the processing of the data from level 0 to higher level products for each instrument. DACs do the ingest, archive, and protect the data and develop specialized tools for the user communities that they work with. Over 3 million people a year use this system, and we distribute about 20 petabytes a year, and we ingest around 4.5 petabytes a year currently. Now we have cross-cutting services, and these cross-cutting services are also open, just like the data are open, right? Because the only way that you can gain the full utility of the products is by having the ability to, well, that doesn't look good at all, but having the ability to access them quickly in a machine-to-machine way. So we have visualization tools that span all the DACs, we have discovery tools that span all the DACs, and we have access and usability capabilities. We have open APIs that people can use to make their own services with our interfaces, and we have some open source clients. In 2015, we determined that we were going to make not only the data open, but all the software used to generate these products, right? And the and the software used to develop the processing workflows open source as well. And you can see two examples on the right-hand side over there. Now, over the next 5 years, you may have seen this in Mike Freilich's town hall a couple nights ago, but we're going to add 17 new instruments to our portfolio of capabilities. And these will be developed by NASA and launched by NASA, but we'll also have international contributions. And we'll integrate these data we'll integrate these data into EOSDIS and provide services on them. So we need to evolve our data management capabilities to support not only the planned missions that you see on here, but also the missions that are going to be a result of the decadal survey. And we need to develop some unique tools because we have new orbits that we're going to be working with. Things like ISS orbits, right, where we put EVI instruments on there, or geostationary capabilities. Now, not only that, but users expect and are increasingly expecting higher performance capabilities out of the data systems to access these products. So as a manager, and this chart kind of scares me, right? So we really bring in around 4 petabytes of data per year today. And within 5 years, we expect to bring about 50 petabytes a year of data in, right? And that poses a challenge for us to manage it, but it also poses a challenge for users to use these products. So we are evolving our systems using commercial cloud technologies at this point to handle these new high rate data missions and to effectively and efficiently manage these products, right? So we've always had kind of a distribution to any one policy. We'll continue that in whatever architecture or location that we put these new systems and data sets, but we're also trying to enable people to process the highly managed, the well-managed data in place from the DACs directly. And we're going to do this all with open source software. Something that you should be aware of if you're interested in funding and developing data system capabilities is that there's an access solicitation out on the street, and that really is asking people to present proposals for things that help with machine learning, advanced search capabilities, cloud optimized pre-processing and data transformation services, right? These are 2-year awards. They'll start sometime next spring or maybe in the summer. There's about $4.5 million per year for all the awards, right? And they're due at the end of January. So if you got a good idea, put it in. And NOIs are desired but not required. You missed the NOI deadline, but you can certainly send me an email and say you're doing it, all right? Now there are 2 ways that we primarily access our information. And I'm going to try to improve the resolution of this. Maybe I can't. To access over 7,500 unique collections of data within our archives. And this upper left-hand corner one over here is called search.earthdata.nasa.gov. So if you know what you're looking for and you know generally where it is, you can use this tool, which is built upon our search engine, to get sub-second search results for granules and metadata and stuff like that, right? And the bottom right-hand corner is the one of the title of this talk today. So let's see. I've only got one hand here, so you'll have to give me a second. So I don't know how many of you are familiar with Worldview, but Worldview is a client that we developed, I guess, starting in 2011, 2012. And it's based on a high-performance tile-based web server, tiled web mapping service called Gibbs. And this provides you access to over 400 layers of information that we collect and generate from satellites nearly every day, right? The data that you see behind here, obviously there's always a tour, so you can figure out how to use these products. But the data that you see behind here when you first open up this tool is the most recent information that we have from, in this instance, the Terra Modis instrument, right? And you can see it kind of goes from the east to the west and stripes the Earth as we go around. It's got all the standard, capabilities of any web mapping client where you can pan and zoom. And if I can do this with my other hand, you can zoom into full resolution, right? So it's pretty quick even on this network here, although it's a lot faster on your own computer. Now there are primarily a number of ways to interact with this, right? So we have all these layers I talked about, and you can click the Add Layers button and kind of peruse through all of the different capabilities that we have, right? And you can overlay these in space and time on these base layers that you see at the bottom here, right? So you can start to see, if you go into air quality, you can see all the very different aerosol optical depth measurements that we have. You can overload those space and time and look at them. You can also access this data via our open API, which is available if you go to earthdata.nasa.gov. Now I'd like to show you some of the unique capabilities that this tool has with regard to working like in the polar areas. So I've pre-selected some information here that really looks at sea ice concentrations detected by a Japanese satellite called GCOM-W with the AMSR-2 instrument, which is a passive microwave instrument. It can look through clouds and see kind of the concentrations of sea ice. And that is combined with the land surfaces, which you kind of see in these gray and blue areas of the freeze-thaw state of the land, right? So you can press play on here, and you can see the dynamics, if it works fast enough on here, of the of kind of the polar ice sheets in from March through the summer and so on and so forth. There are a number of unique tools on here to change the orientation, to do those types of things. We also deal a lot with responding to emergencies and working with other divisions within, or other departments within the Earth Science Division, right? So we work a lot with our Applied Science Division. We work a lot with our RNA divisions to make sure that they have the capabilities that they need to understand the information as quickly as possible. And in this instance, we can take a look, and maybe many of you have seen this on the news or on Twitter or whatever, where Miguel Roman has developed a night lights product using the VIIRS instrument from NOAA, right, and makes this available in near real time for people to evaluate. And if you look at a kind of a pre-Maria picture here, and you kind of zoom over to a post-Maria picture here, you can see dynamically over the course of a month the reduction in the amount of emitted light from the island. And even if you go into the early December, that same situation still applies. It's taken a long time to recover, and you can look at the night lights to do that, right? You can see how long many of these areas take to recover. The other thing is we deal a lot with, and this is kind of where a lot of these activities initially started, in terms of rapid response for fire management, right? So if I turn this off and I look back here in kind of the Los Angeles area earlier this month, and I step through it day by day, and some of these data products go back, I think, to 2003 currently, and we're trying to go back to the beginning of the mission for many of them. And we keep on going forward. You can start to see the giant smoke plumes in the Santa Barbara area. You can overlay on that the hot spots related to the locations of those fires. And if you look at night, you can also see the co-location of the hot spots with this giant bright blob, which is also a fire. And if you go back to the night before, you see that that doesn't exist. Anyhow, you can explore multiple components of your world with this Worldview client. And you can access the data underneath this and develop your own clients using some of our open source software. Finally, I'd just like to show you these pictures because these are some of the most beautiful ones that we have. They selected some good color palettes for this while I take some questions. And this is really the sea surface temperature product that is jointly developed by scientists at NASA and at international agencies at NOAA to develop the best representation of sea surface temperature globally. So I got about a minute for some questions.